Okay, so this lesson is going to be a review of the Pythagorean Theorem. So take a minute if you need to pause the video and jot down or write out or keep in your head. If you can remember what the Pythagorean Theorem is, go ahead and pause and get that going in your head right now. Okay, hopefully you have paused and returned, and you've remembered what the Pythagorean Theorem says. If not, I'll give you a little hint before we dive into it. The Pythagorean Theorem has to do with right triangles. Does that ring any bells? It talks about the legs of a triangle and the hypotenuse of the right triangle. It involves the lengths of the legs and the hypotenuse. I hope at this point, if you hadn't already, you now remember the Pythagorean Theorem. A squared plus B squared equals C squared. That is the length of side A plus the length of side B. When you square each of those side lengths, will equal the length of the hypotenuse squared, or C. And what this does for us is it helps us figure out if we are not given every side of a right triangle or things that make right triangles in real life, or we can use this theorem, this formula, to find them. So let's prove this theorem, this formula. Let's prove it with a right triangle that you will see pop up in real life quite often. I'm going to draw a right triangle with sides A equaling 3, side B equaling 4, and side C, or the hypotenuse, equaling 5. And remember, if I don't give you a unit of measure, inches, centimeters, then it is units. And in this case, we're just going to call it units. So by this theorem, we should be able to take 3 squared plus 4 squared, and it should equal 5 squared. Well, let's see it. Let's try it out and see if it happens. 3 squared, well, that's the same as 3 times 3, and 3 times 3 is 9. 4 squared is the same as 4 times 4, which is 16. And we hope that that equals 5 squared, and 5 times 5 is 25. Okay? I'm trying to make my left side equal my right side of 25. Is 9 plus 16 25? Well, if we count on 9 from 16, we find that yes, it is 25. And 25 is equal to 25. So therefore, these side lengths, A of 3, B 4, C 5, all work together to prove the Pythagorean theorem that when you have the side A squared plus side B squared, it will equal the hypotenuse C squared. So I'm going to take a moment to erase this, and we're going to do one problem together and try and find the hypotenuse of a right triangle. So I'm going to have a right triangle, and again, I'm just drawing freehand here, so things may not be to scale. You just got to trust me when I tell you what the side lengths are, okay? So I'm going to do a right triangle with the side lengths 9, and let's see here, we'll do 12. And see, what is the side length for C? All this is using the Pythagorean theorem and what we know about solving equations to find C. Now, this is where I don't want you to get confused. We're not looking for C squared. We're looking for C. Okay? So now we go through and we start filling in the things we know for our equation. Do we have a side length A? Yes, we do. It's 9. So we'll stick that in here, 9 squared. Do we have a side length for B? Yes, we do. It's 12. We'll stick 12 squared in here. And do we know C? We do not, so it will stay the same. Now I'm going to draw my river and go through my problem solving or my equation solving steps. So when we solve an equation, we look first and see if there's any like terms, anything that we can put together. Right. We also think about the order of operations, right? PEMDAS. We look for things in parentheses. We look for exponents. We look to then multiply or divide from left to right. And then we look to add or subtract from left to right. So let's look here. Do we have anything in parentheses? We do not. Do we have exponents? We do. We do have exponents. We've got 9 squared, which is the same as 9 times 9. And 9 times 9 is 81. Okay. We've got another exponential thing. We've got 12 squared. And 12 times 12 is 144. And we still don't know what C or C squared is, so it will stay. Okay. We don't have anything to multiply or divide. So now we look, do we add or subtract from left to right? We can. 81 plus 144. 144, let's make that screen bigger again. There we go. 144. Well, this does not want to cooperate. Let's try one more time. 144, there we go, plus 81. 4 plus 1 is 5. 8, 9, 10, 11, 12. And I bring my 1 plus 1 is 2. 225. Okay. So 81 plus 144 is 225. And 225 is equal to C squared. All right. We are almost done. Remember, I told you that we are not looking for C squared, though. We are looking for C. We're looking for C. Okay. If I've got C, this is not cooperating. If I've got C that I need to get, but all I have is C squared, how can I get rid of this exponent? Well, the opposite of squaring something is taking the square root. So let's take the square root of C squared. And remember, if I do it to one side of an equation, I have to do it to the other because we keep our equations balanced. The square root sign and your square, they go away. They cancel each other out, and we're left with C. Okay, that's what we need. And now we just need to find the square root of 225. If you have a calculation device, your phone, your computer, a calculator, that's great. Go ahead and find the square root of 225. You might also just remember it from when we did our unit on squares and cubes. And if you have your notebook with that in it, that's great too. You can always just look that information up. But however you find it, you will see that the square root of 225 is 15. That means that my hypotenuse of this triangle right here is 15 units. 15 units. Okay. Let's erase all of this, see if we can't get things back to normal. So remember, when you are going through this, hopefully most of your problems that you receive will be, let's try that, will be things that involve perfect squares so that you don't have to rack your brain too much. If not, though, let's do an example of a right triangle that's not going to give us a perfect square. That's going to have us have our answer in a little different way. Okay? We're going to call this 2. We're going to call this 3. And we're going to say, what is the hypotenuse C? Well, I start with my formula, a squared plus b squared equals c squared. And then I begin to fill in the things I know. Do I have an a squared? I do, it's 2. Do I have a b squared? I do, it's 3. Do I know my c? I don't, so it stays. And now I begin to solve my equation. 2 squared is 2 times 2, and 2 times 2 is 4. And 3 squared is the same as 3 times 3. 3 times 3 is 9. And when I look over here, I still don't have a c or a c squared, so it stays. Now, I have to combine my left side. 9 plus 4 is 13 equals c squared. And I hope that you're realizing that we're about to hit a snag, that 13 is not a number that has a perfect square root. So we're trying to get c by itself, and I'll show you how to tackle that in a second. We're trying to get c by itself. It has a squared sign attached to it, this exponent. To undo a square, we take the square root, and if we do it to one side, we do it to the other. Those cancel, and you're left with c. And then you've got over here the square root of 13. In most cases, unless you are told otherwise, I want you to keep your answer just like that. You keep it with the square root symbol over your whole number if it is not able to be broken down into a perfect square, right? Perfect squares are 4, that's 2 times 2, all right, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on and so forth. If your answer isn't one of these numbers, or the so on and so forths, right, then I want you to leave it as the radical over your number, okay? So that means that c, its length is the square root of 13 units. Now, there may be questions that ask you to give an approximate answer. And it'll tell you if it wants an approximate answer, then the question will say, round your answer to the nearest whatever, tenths, hundredths, thousandths. You read your problem and let it tell you, okay? So in this case, if we want an approximate answer for C, then I need to use my calculation device and find the square root of 13. And you will see when you type yours in that the square root of 13 is something along the lines of 3.60555 and so forth. Okay? If it tells you to round to the nearest tenth, it would be 3 6/10. The nearest hundredth would be 3 61/100. The nearest thousandth would be 3 606,000ths, right? We're just rounding, which you are all very good at and know how to do. But you will only give me this type of approximate answer if it asks. If it does not specify, then you give it to me with the whole number and the radical sign, okay? That is all I want to look at for now. I will upload another video in the coming days talking about some of the other parts of our geometry review quiz. And don't forget, we have a Zoom meeting coming up on Thursday at 10 a.m. I will be sending you a link to join in your email, your school email. So check that tonight, tomorrow morning. I'll probably send it this evening. So if you check it in the morning, you'll know it'll be there. Okay? And when we have this Zoom meeting, you will be able to ask any questions you have about this first packet, the geometry packet. Okay? All right, guys. We'll talk to you later. See ya.